In this lesson, I'll show you how to find the quantum numbers. The question reads, what are the quantum numbers and names of the orbitals in the n is equal to 4 principal level, and how many n is equal to 4 orbitals exist? To answer this question, you first need to determine the possible values of L, and L stands for the orbital angular momentum. To find out what the L value is, or the maximum L value, you take n and subtract it by 1. In our case, n is equal to 4. 4 minus 1 is 3. And as you can see in the chart underneath, if L is equal to 3, we have to denote 0, 1, 2, all the way to 3. Using this chart, we can start to find the magnetic quantum number represented as m sub L. So for a given value of L, let's say 0, the possible values of m sub L are the integer values including 0, ranging from negative L to positive L. So for the first one, the only possibility is 0. For the second one, when L is equal to 1, it ranges from negative 1 to positive 1, and the same pattern applies to 2 and 3. If you count all of these up, you should end up with 16, and that's the total number of orbitals. That can also be found by taking n and raising it to the power of 2. So we have 4 to the power of 2, we should have 16 orbitals. Now we're also asked to name the orbitals. When you have one orbital, it's 4s, 3 orbitals is 4p, 5 orbitals is 4d, and 7 orbitals is 4f. 4 in all of these relates to the value of n. That being said, let's try out question 2. The question asks, list the quantum numbers associated with all of the 5d orbitals, and how many 5d orbitals exist. Remember that over here we had all 4s and s, p, d, and f. The 4 stands for n. Here it's 5d, so we're told that n is equal to 5. They're asking to list the quantum numbers, so m sub L, and how many orbitals exist at 5d. Well, let's go ahead and do this. First, let's find out what L is, and L is equal to 4. We can create our chart similar to the way that we created this one. We'll have 0, 1, 2, 3, and 4. This is our L column. The possible magnetic quantum numbers for these are 0, minus 1, 0, and plus 1. Here we have minus 2, minus 1, 0, and 1 to 2. And the same thing for these. Now let's fill in the orbital names. So once again, these were m sub L, and this will be represented as the orbital names. So I'll write down names. The first one is S, then P, then D, and that's where we'll stop because they're asking how many 5d orbitals exist, and the answer is 5. Let's see if we've completely answered this question. List the quantum numbers associated with all 5d. We've done that, highlighted. And how many orbitals exist at 5d? It's 5. And there you have it. That's part 1 to quantum numbers. Make sure that you watch part 2 where we tackled different examples. We'll see you soon.